Draw the rough sketch of the curve y is equal to 20 times cos 2x, where x lies between pi by 6 and pi by 3. And using integration, find the area of the region bounded by this curve from the ordinates x is equal to pi by 6 to pi by 3 and x-axis. Let's sketch the graph. Let's take the points pi by 6 30 degrees and pi by 3 60 degrees. So between 30 and 60 we can take 45 degrees also, pi by 4. So here y is equal to 20 times of cos 2x. So let us take the x value and y value. When x is equal to pi by 6, cos 2x is equal to cos 2 pi by 6, that is cos pi by 3, which is 1 by 2. So y is equal to 20 times cos 2x. So 20 into 1 by 2, which is equal to 10. So when x is equal to pi by 6. Now when x is equal to pi by 4, so cos 2x is equal to cos 2 into pi by 4, that is pi by 2. Cos pi by 2 is 0. So here we can get 20 into 0 is 0. And now when x is equal to pi by 3, cos 2x is equal to cos 2 pi by 3, that is cos pi minus pi by 3. Second quadrant cos negative, so minus cos pi by 3, which is equal to minus 1 by 2. So we can write 20 into minus half, which is equal to negative 10. So let's mark these points on the graph. When x is equal to pi by 6, it is 10. So let's here 10, 0, 10 point. So pi by 6, 10, and pi by 4 it is 0, and pi by 3 it is minus 10. So let's consider here 0, minus 10. So the graph can be taken as since we know that this is a region between pi by 6 and pi by 3. So this is a graph we can consider. And now the area of the region bounded by this curve from x is equal to pi by 6 to pi by 3 and x-axis we can consider. So this is the required region. So from pi by 6 to pi by 4 we are in the positive direction of y-axis, and pi by 4 to pi by 3 it is in the negative direction, negative of y. So we need to write the area required integral pi by 6 to pi by 4 20 times cos 2x dx plus integral pi by 4 to pi by 3 mod 20 times cos 2x dx. So this can also be written area is equal to 20 times integration of cos 2x is sin 2x divided by 2 over the limits pi by 6 to pi by 4 plus here 20 times mod sin 2x divided by 2 over the limits pi by 4 to pi by 3. That is 10 times sine 2x over the limits pi by 6 to pi by 4, and again here 10 times mod sine 2x over the limits pi by 4 to pi by 3. So I can take even 10 common, and here sine 2x upper limits, if I apply sine 2 into pi by 4 minus sine 2 into pi by 6, and again here mod of sine 2 into pi by 3 minus sine 2 into pi by 4, which is 10 times sine 2 into pi by 4 is pi by 2, sine pi by 2 value is 1 minus, and here 2 into pi by 6 is pi by 3, sine 60 is root 3 by 2. So 1 minus root 3 by 2, and again here the mod sine 2 into pi by 3 is sine 2 pi by 3 value pi minus pi by 3. In the second quadrant sine is positive, so we can write sine pi by 3, which is root 3 by 2. And again minus sine 2 into pi by 4 is pi by 2, sine pi by 2 value is 1. So 10 times, and here we know that root 3 by 2 is smaller than 1. So we may consider 1 minus root 3 by 2 plus, we need to write 1 minus root 3 by 2. Because root 3 by 2 minus 1 is negative, so we are applying the minus of that. So minus of 1 minus root 3 by 2, that is 1 plus 1 minus root 3 by 2. So which is equal to 10 times of 2 minus root 3 by 2, root 3 by 2 is root 3. Or we can write 20 times 1 minus root 3 by 2 square units is the required area. Okay, thank you. Given that the equation of the path traversed by the ball headed by the footballer is y is equal to ax square plus bx plus c, which is a parabola where x lies between 0 and 14, and a, b, c are real numbers, and a is not equals to 0. So with respect to the xy coordinate system in the vertical plane, and the ball is passing through the points 2, 15, 4, 25, and 14, 15. And we need to determine the values of a, b, and c, solving the system of linear equations in a, b, and c using matrix method. Also find the equation of the path traversed by the ball. It's given, say this is x-axis, say it's y-axis. The path traversed by the ball is the parabola equation, and a is not equals to 0. So we can say this is how the ball can travel. And it passes through the points 2, 15. Let's say this point is 2, 2, 15. Say this point is A, and 4, 25. Say this point is B, 4, 25. And the next one 14, 15. So this point is C, 14, 15. And the equation is y is equal to ax square plus bx plus c. So when x is equal to 2, so we can write y is equal to a into 2 square plus b into 2 plus c. So that is y is equal to 4a plus 2b plus c. So y value is 15. So we can write, so 15 is equal to, so 4a plus, we can write 4a plus 2b plus c is equal to 15 is one equation. Similarly, when x is equal to 4 and y is equal to 25, so we can write 25 is equal to a into 4 square plus b into 4 plus c. So which gives the equation 16 times a plus 4b plus c is equal to 25. And next 14 comma 15, when x is equal to 14 and y is equal to 15, so we can write 15 is equal to a into 14 square plus b into 14 plus c, which implies, so 196 times a plus 14 times of b plus c is equal to 15. So these are the three equations, we got it. So representing the three equations in matrix form as, so we can write 4, 2 and 1, 16, 4 and 1, 196, 14 and 1. Here the variables are here ABC. ABC matrix is equal to constants are 15, 25 and 15. So which is in the form of AX is equal to B. And to solve it, we need to apply X is equal to A inverse into B inverse method. To verify whether matrix inverse method is applicable or not, we need to identify, or we need to make sure that determinant A is not equals to 0. So let's find the determinant of A. It's a coefficient matrix. So we have 4, 2 and 1, 16, 4 and 1, 196, 14 and 1. Let's find the determinant. 4 times of 4 ones are 4, 4 minus 14, minus 2 times of 16 ones are 16, minus 196, and again plus 1 times of 16 into 14, so we can say 224, minus 196 into 4, so we can say 784, which is equal to 4 times of minus 10, minus 2 times of, we can say 1 minus 180, plus 1 times of 224 minus 784 is minus 560, which is equal to minus 40, minus 40, and again plus 360, minus 560. So 360 minus 560 is minus 200, and here it is minus 240, we can say minus 240, which is not equals to 0, and hence determinant is not equals to 0 means matrix inversion method is applicable, means A inverse exists. Now let's find the inverse of the matrix A. We have A inverse is equal to 1 by determinant of A into adjoint of A. So let's find the adjoint of A. Since A is equal to 4, 2 and 1, 16, 4 and 1, 196, 14 and 1. So let's use the shortcut method to find the adjoint. Start taking from the second row, second element, second row, second column element. Start writing here 4 and then 1 and then again 16 from the same row, second row, and then ending again end with 4. So writing 4, 1, 16, 4, and coming to the next row. So start from the second column element, that is 14, 1, and again 196, and again end up with 14. And coming to the next row, first row. So start with the second column element, that is 2, same process 2, 1, and again 4, and again end with 2. And again this process end with again the second row. So 4, 1, 16, and 4. Now let's find the determinants here. Let's find the determinants and write in transpose way, because adjoint of A is nothing but transpose of the cofactors matrix. So these are cofactors. 4 into 1 4 minus 14 ones are 14. So 4 minus 14 is negative 10. So let us write here minus 10, and here 14 ones are 14 minus 2 ones are 2. 14 minus 2 is 12. Instead of writing column, we have to write in the row wise. So it is 12, and again 2 ones are 2 minus 4 ones are 4. 2 minus 4 is negative 2. So I can write here negative 2. And now coming to the second row here, we need to perform the second column here. So 196 minus 16, so it's 180. So I can write 180 here. And next, 1 4s are 4 minus 196, that is minus 192. So let us write minus 192. And here 16 minus 4 is 12. So second row completed, and third row 16 into 14 minus 196 into 4. This calculation we can get minus 560. And here 196 into 2 minus 14 into 4, the calculation comes to 336. And 4 4s are 16 minus 32. It's a negative 16. So we got direct adjoint of a matrix. No need to do transpose. We have done already transformation. And then A inverse is equal to 1 by determinant of A is minus 240 into adjoint of this matrix is minus 10, 12, and minus 2, 180 minus 192 and 12, and minus 560, 336, and negative 16. Okay. Now we have X is equal to A inverse into B. Let us do it. So we have X is equal to A inverse into B, that is ABC variable matrix, which is equal to A inverse is minus 1 by 240 times minus 10, 2 and 12 and minus 2 and 180 and minus 192 and 12 minus 560, 336, and again negative 16, and the constant matrix is 15, 25, and 15. So here we can take 2 as a common, and here 5 as a common, so that we can write minus 1 into 2 into 5 divided by 240. So when 2 is taken common from the first matrix, we can write minus 5 and 6 and minus 1, and here 90 and minus 96 and 6, and again the next minus 280 and 168 and minus 8. So multiplied with the constant matrix when 5 is taken common. So 3, 5 and 3. So let's multiply here. So minus 10 divided by 240. So we can add minus 5 into 3 is negative 15 plus 6 5s are 30 and minus 1 into 3 is minus 3 and 90 into 3 this is 217 and minus 96 into 5 it's 480 and 6 threes are 18 and again here minus 283s are minus 840 and 168 5s are again 840 and minus 24, that is minus 1 by 24 times. So of calculation, so we'll be getting 12 and here it comes 192 minus 192 and here it is minus 24. So which comes here 12 upon 24 minus 1 by 2 and 192 divided by 24 is 8. So minus minus gets cancelled. So it is 8 and here it comes 1. So here we can conclude that therefore the value of A is equal to minus 1 by 2 and the value of B is 8 and the value of C is 1. And hence we can give the parabolic path, that is path traversed by the footballer, y is equal to minus 1 by 2 x square plus 8x plus 1 is the answer. Okay. Given function f from R to R real numbers to real numbers defined by f of x is equal to mod x whole power 3. We need to show that f double dash of x, that is second order derivative of the function f, exists for every real number and we need to find it. So we know that mod x is equal to plus x when x is greater than or equals to 0 and negative x when x is less than 0. So here we can write negative x whole power 3 when x is less than 0 and positive x power 3 when x is greater than or equals to 0. That is f of x is equal to negative x power 3 when x is less than 0 and x to the power of 3 when x is greater than or equals to 0. Now the derivative, left hand derivative, limit extends to 0. We have f of x minus f of a, that is f of 0 divided by x minus 0, which is equal to the limit extends to 0. F of x value we can write in the left hand derivative, that is 0 minus. So below 0 is minus x power 3 minus f of x value is 0 divided by x minus 0 is x. So limit extends to 0. So we can write minus x square divided by minus x square will get, which is equal to 0. Similarly the right hand derivative, if we see the right hand derivative, the limit extends to 0, 0 plus f of x minus f of 0 divided by x minus 0, which is equal to the limit extends to 0. 0 plus means above 0 we can at x power 3 minus 0 divided by x minus 0, that is x. So which is equal to the limit extends to 0, x power 3 upon x is x square, which is equal to 0. So here we can say left hand derivative is equal to right hand derivative. Left hand derivative is equal to right hand derivative at x is equal to 0 for the function f. So we can say f dash of x exists. So f dash of x can be taken as, so derivative of the function f dash of x is equal to differentiation of x power 3 is 3x square. So it is minus when x is less than 0 and when x is greater than 0 3x square when x is greater than or equals to 0. Now again, to find the left hand derivative and right hand derivative for the double differentiation, we need to check whether the derivative exists or not. Left hand derivative, limit extends to 0. Again the concept f of x minus f of 0 divided by x minus 0, which is equal to limit extends to 0. F of x value is, if it is below 0, minus 3x square minus 0 divided by x. So that is minus 3x. And limit extends to 0, the value will be taken as 0. Similarly, right hand derivative, limit extends to 0 plus f of x minus f of 0 divided by x minus 0, which is equal to limit extends to 0. F of x, if it is above 0, we can consider 3x square minus 0 divided by x minus 0. We will be getting 3x limit, which is equal to 0. So here also left hand derivative is equal to right hand derivative. So we can define f double dash of x, which is equal to differentiation of 3 minus 3x square is minus 6x when x is less than 0, and differentiation of 3x square is 6x when x is greater than or equals to 0. So the double differentiation exists and the value is minus 6x when x is less than 0 and 6x when x is greater than or equals to 0. This is the answer. Given that x minus a whole square plus y minus b whole square is equal to c square, for some c is positive, we need to prove that 1 plus dy by dx whole square whole to the power 3 by 2 upon d square y by dx square is a constant that is independent of a and b. So let us go with the trigonometric substitution. Let x minus a is equal to c cos theta and y minus b is equal to c sin theta. So that x minus a whole square plus y minus b whole square will become c square of cos square plus sin square, which is 1 c square, which satisfies this equation. Now differentiating with respect to theta, we have dx by d theta is equal to c into differentiation of cos theta is minus sin theta. Similarly, y minus b is equal to c sin theta. Differentiate with respect to theta, we have dy by d theta is equal to c times of differentiation of sin theta is cos theta. So from 1 and 2, we can write dy by dx is equal to dy by d theta upon dx by d theta. That is c into cos theta divided by minus c into sin theta. That is negative cot theta. And now again differentiation, d square y by dx square is equal to d by dx of dy by dx, that is minus cot theta. So we can write differentiation of cot is minus cosecant square theta minus of minus cosecant square theta into d theta by dx. So which is equal to cosecant square theta, and dx by d theta is minus c sin theta. So we can write d theta by dx is nothing but minus 1 upon c sin theta, or we can write minus 1 by c cosecant theta. So we can write minus cosecant cube theta divided by constant c. Now let us substitute here 1 plus dy by dx whole square, that is minus cot theta whole square whole to the power of 3 by 2 divided by d square y by dx square, that is minus cosecant cube theta divided by c, which is equal to 1 plus cot square theta whole to the power 3 by 2 divided by minus cosecant cube theta divided by c, that is into c. So 1 plus cot square is nothing but cosecant square theta. So we can write here cosecant square theta whole to the power of 3 by 2 into c divided by minus cosecant cube theta. So cosecant square into whole power 3 by 2 is nothing but cosecant cube theta. So the numerator and denominator both gets cancelled. So which is equal to negative c, which is independent of independent of the constants here a and b. So we can go with an answer here. The simplification is constant minus c. Okay. Given two line equations L1 and L2, R is equal to minus I minus j minus k plus lambda times of 7i plus 6 minus 6j plus k, and another line equation 3i plus 5j plus 7k plus mu times of I minus 2j plus k. We need to find the shortest distance between them, where lambda and mu are the parameters. So first line equation L1, so given R is equal to minus I minus j minus k plus lambda times of 7i minus 6j plus k. So which is in the form of, we can write R is equal to a1 plus lambda times of b1. And now the second line equation, given the line equation 2 second, R is equal to 3i plus 5j plus 7k plus some constant mu times of I minus 2j plus k. So let us consider it is in the form of R is equal to a2 plus lambda of b2. So here b1 vector is 7i minus 6j plus k, and b2 vector I minus 2j plus k. So clearly we can say that b1 and b2 they are not proportional, or means b1 by b2 is not constant. So b1 is not parallel to b2 we can consider. And now the shortest distance between these two formulas, r is equal to a1 plus lambda of b1 and r is equal to a2 plus lambda of b2. So we can have the formula shortest distance is b1 cross b2 dot a2 minus a1 divided by mod of b1 cross b2. So let's find the b1 cross b2 here. So ijk in the first row, and here first b1 matrix b1 vector 7 minus 6 and 1, and b2 is 1 minus 2 and 1. So the determinant value we can write I times of minus 6 plus 2 is minus 4, minus j times of 7 minus 1 is 6, plus k times of minus 14 plus 6, that is minus 8. Or we can take 2 common and write minus 2 common, 2i plus 3j plus 4k. So this is b1 cross b2, and mod of b1 cross b2 is, so we can take 2 common, under root of 2 square is 4, 3 square is 9, 4 square is 16, that is 2 root 16 plus 9 25 plus 4 29. So mod of b1 cross b2 is 2 root 29, and then a2 minus a1, here a1 vector is minus I minus j minus k, and a2 vector is 3i plus 5j plus 7k. Now a2 minus a1, we can write it as 3 minus of minus, that is 4i, 5 minus of minus, that is 6j, 7 minus of minus 1, that is 8k. Or we can take 2 common, 2i plus 3j plus 4k. So a2 minus a1 vector we got it. So finally the shortest distance formula, let us substitute here. b1 cross b2 is minus 2 times of 2i plus 3j plus 4k into dot product with a2 minus a1, that is 2 times of 2i plus 3j plus 4k divided by mod of b1 cross b2 is 2 root of 29. So which is equal to minus 2, 2 gets cancelled here, 2 times minus 2 times of, and let's do the dot product here, 2 into 2 4, 3 into 3 9, 4 into 4 16 divided by root 29. So that is minus 2 into 29 divided by root 29. So 29 upon root 29 is root 29. So we can write 2 root 29 is the shortest distance. Since it is a distance, we have to ignore the negative. So 2 root 29 units is the shortest distance between the two line equations, two lines. We need to find the image of the point 1 comma 2 comma 1 with respect to the given line. X minus 3 upon 1 is equal to y plus 1 upon 2 is equal to z minus 1 upon 3. Also find the equation of the line joining the given point at its image. So let the point P be the point, given point 1 comma 2 comma 1, and the line equation x minus 3 upon 1 is equal to y plus 1, we can add y minus of minus 1 divided by 2 is equal to z minus 1 upon 3. So which is in the form of x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So since this line is passing through the point x1 comma y1 comma z1 and having direction ratios as a comma b comma c. So here passing through, so this line is passing through 3 comma minus 1 comma 1 and having direction ratios 1 comma 2 comma 3. Let's see this point P 1 comma 2 comma 1, and here is a line equation, and we need to find the image of this point P with respect to this line. Let's say Q alpha, beta and gamma. Let the point Q alpha comma beta comma gamma be the image of point P with respect to the given line L, and let M be the midpoint which is on the line. Let M be the midpoint of P and Q which lies on L. So let's take the general point. Since we know that x minus 3 upon 1 is equal to y plus 1 upon 2 is equal to z minus 1 upon 3. So let us consider 2 b is equal to some constant, some lambda, which implies x is equal to 1 lambda plus 3 and y is equal to 2 lambda minus 1 and z is equal to 3 lambda plus 1. So we got x value, y value and z value. So that the point M is coordinates of point M lambda plus 3, 2 lambda minus 1, 3 lambda plus 1. Also we can see that this PM is perpendicular to the given line, and hence the direction ratios of these both are perpendicular. The dot product should be equal to 0. Let's find direction ratios of given line, say B1. So we have 1 comma 2 comma 3. Let's find the direction ratios of line joining P and M. So point P is 1 comma 2 comma 1 and point M is lambda plus 3 comma 2 lambda minus 1 comma 3 lambda plus 1. So the direction ratios can be taken as lambda plus 3 minus 1, 2 lambda minus 1 minus 2 and 3 lambda plus 1 minus 1. We know that the direction ratios are x2 minus x1, y2 minus y1 and z2 minus z1. That is lambda plus 2 comma 2 lambda minus 3 comma 3 lambda. So these are the direction ratios, say B2. And we know that this, since line L is perpendicular to PM, so the dot product will be equal to 0. So we can write lambda plus 2 times of 1 plus 2 lambda minus 3 times of 2 plus 3 lambda times of 3 is equal to 0. That is lambda plus 2 plus 4 lambda minus 6 plus 9 lambda is equal to 0. So 1 lambda plus 4 lambda 5 lambda plus 9 14 lambda. 2 minus 6 is minus 4 is equal to 0. So that is lambda is equal to 4 upon 14, that is 2 upon 7. So we got the lambda value 2 by 7. So the point M can be taken as 2 by 7 plus 3, 2 into 2 by 7 minus 1, 3 into 2 by 7 plus 1. That is 7 3 is a 21 plus 2, 23 divided by 7 comma 2 to the 4 and here 7, 4 minus 7 is minus 3 upon 7 comma and here it is 7 plus 6, 13 divided by 7. So 23 by 7 minus 3 by 7 and 13 by 7 is the point M. And now Q, the point, is the midpoint. So sorry, M is the midpoint. So we can write 1 plus alpha divided by 2 is equal to 23 by 7 and 2 plus beta divided by 2 is equal to minus 3 by 7 and 1 plus gamma divided by 2 is equal to 13 by 7. So on simplifying we can write 1 plus alpha is equal to 23 2s are 46 divided by 7. So that is alpha is equal to 46 by 7 minus 1. So we can write 39 divided by 7. So the value of alpha is 39 by 7 and now for beta 2 plus beta upon 2 is equal to minus 3 by 7. So we can write 2 plus beta is equal to minus 6 upon 7. So beta is equal to minus 6 by 7 minus 2, that is beta is equal to minus 20 divided by 7. And then gamma 1 plus gamma by 2 is equal to 13 by 7. So what we can write 1 plus gamma is equal to 26 divided by 7. So gamma is equal to 26 by 7 minus 1, that is 19 divided by 7. So we got it finally, alpha value, that is image of the point, image of point P 1 comma 2 comma 1 with respect to the line L is given by Q 39 divided by 7 minus 20 divided by 7 and 19 divided by 7. So we got the image point and now the equation of the line, since it is passing through the point, since this line is passing through the point P and having the direction ratios as the PM, that is direction ratios we can consider here. So we can write x minus, so direction ratios of the line, let us write here 39 by 7 minus 1. Let me write directly x minus x1, that is 1, divided by 39 by 7 minus 1 is equal to y minus 2 divided by, so we can write minus 20 divided by 7 minus 2 is equal to z minus 1 divided by 19 divided by 7 minus 1, that is x minus 1 divided by 39 minus 7, that is 32 upon 7 is equal to y minus 2 divided by minus 20 minus 14, that is minus 34 divided by 7 is equal to z minus 1 upon 19 minus 7, that is 12 divided by 7. On simplifying, we can write x minus 1 upon 32 is equal to y minus 2 upon minus 34, which is equal to z minus 1 upon 12. That is x minus 1 by, we can cancel with the two tables, 16. Y minus 2 upon minus 17 is equal to z minus 1 upon 6. So this is the required line equation of PQ, and image point is 39 by 7 comma minus 20 by 7 comma 19 by 7. Okay.